Okay. So given an SSA case where two solutions are possible, you indeed have two possible answers or solutions for the remaining unknown values. The ones, whatever happened there, the ones you're given remain unchanged. So the ones that they give you, obviously those numbers are not going to change, but the other ones are. Okay, so let's make sure you turn on your thinking, the switch on your brain, right? Just turn it on right about now, and let's go through this. Okay, so you get information. Obviously, I'm very much SSA the whole time, right? And so there's D and there's D there. That's my pair, and I have another side. I'm not going to highlight that, but I definitely know that this is an SSA scenario. And I'm going to focus on the acute, because the acute, when the angle given is acute, that's the only time where you have to go through this whole mess, right? Because twos, it's either 0 or 1, right? Like you only have either 0 triangles, which you can't solve it. If you ever try to do one that has no solutions, you're going to get an error on your calculator. You're going to start and you're going to do everything right, and it's going to give you an error. That means that it cannot be done. It doesn't exist. Okay. So here we go. Let's go through the motions of actually justifying how many solutions are possible. Okay, so let's go through this. So this part, you should all be like, yep, I know what's happening here. This is 25 miles, and this is 30 miles. Okay. Let me just get. I'm saving room because I need room. There's a reason why this whole page is empty. And let's just make sure we understand that this side here is side D, right? Lowercase d. And the other side that I'm provided with is side F. So we got to make sure we understand that, right? D and F. And to make matters worse, right, we still always talk rod and string. Okay, let me zoom into that for a bit so your eyes won't have to work that hard. There. So DD, so angle over here where my pencil is, that is if we determine that there's a triangle, that's going to be angle F, right? For now, I'm not writing it in because I'm not sure if I will be able to close this thing. So we determine that string, right? The measurement of the string is less than the rod, right? So I have to find the height. And so that's 30 times sine of 27. So you have to bear with me for the first little bit because this is somewhat repetitive. We've done this many times. And this gives you 13.62. miles. And now I'm going to make my conclusion here. Right? Once I have the height and the string, I will do this over here. Okay. I will say that the string is greater than the height. And if you ever need, if you ever need to do this, go for it, right? 25 miles is greater than the height, which is 13.62, right? Like if you need the numbers also on top of the string and height, go for it. There's nothing wrong with it. So therefore, we'll have two solutions. When the string is greater than the height, you have got two solutions there. And now it's asking you to solve for side E. Now we do know that there are two possible solutions for side E. That's the problem. And here's what happens. So imagine we're going to take this one and now close it because we know that one of them looks like this. One of them looks like this, like when that arm swings out and it touches here on the further point. And this is D, like I'm basically keeping most of the information intact. 25 miles. Side F is 30 miles. I'm just taking the top one and just rewriting it. Now I know it's going to close it. So what angle is on this corner right here? Angle F, right? Because I've determined that side F is here. And what's the other letter? What do I need still? It's DEF, right? So you make the one remaining one up here, you make that your E. I like to have this one first. And when this side swings over and closes it here, that's going to be my second triangle. Okay, so imagine this swinging over and closing it here. So I'm doing one of these. Okay, so we go D, E, F, same angles, right? And F is 30 miles. That has never changed. So the three things that you're given off the bat are never changed. Okay. So make sure you have those two side by side. Okay. And we need to distinguish, right? This angle here is not the same as that one there. Okay. So we go F sub 1, F sub 2. Okay. What about the angle up top, E? They will also not be the same. So I got to go E sub 1, E sub 2. What about side E, the one they really want? That's what the question is asking me for, solve for side E. So I have to go through the motions, like, oh, there's actually two triangles here. So it could be lowercase e1, it could be that, this longer side, or it could be the shorter side, which is lowercase e2. That is what the question is really asking me for. Okay, is it this one or is it this one? Well, we will never know for sure, so we will have to answer it's either this or that. Right? So that's where the problem arises. So let's get started. I always start with this one. Start here. This is the one I start with, and I will explain to you why. It really, in theory, doesn't matter, but it does matter when you're busy and you're like time is ticking and you're like, I want to get this done. There's that one issue that arises if you start with this one. Okay, so let's get going. So we have a pair. Obviously, this is sine law because it's an SSA, right? And so this is my pair. And the only thing that I can solve for is this angle here because I do have this side across from it. So I'm just going to go 30 sine. You have to make sure you keep the subscript consistent, or else you'll make a mistake. So sine of f1, make sure you write this down, okay, is 30 times sine of 27 divided by 25. I will just go straight to angle f1 is sine inverse of, I think you all understand that you have to multiply and divide, so I'm just going to give you the number here. Just write it down. And I'm using all decimals, so I'm just going to do one of those. And here's angle f1. So the solving part, you should all be like, yep, I know how to do that. It's the keeping things separate and knowing what to do when that is going to be crucial. So figure that out. And that is 33.01 degrees. I will underline that because that's not really answering the question just yet. So we have F1. We can now find angle E2. Sorry, E1. I can find E1, right? Because I have two angles now. I can find that third one. Just use sum of 180, right? So 180 minus 27 minus 33.01. So angle E1, when you subtract these all, you get 119.99 degrees, which is also important to me, but I'm not going to box it in because that's not the final answer. Now, yeah, right. So I'm going to just leave it there for now. Sure you write that down. So I started with that one. I solved for the one angle. Now that I have two, I can solve for the third angle. So all angles are taken care of. Okay. And here's something that I would like you to see. Now pay close attention to this part. Now that I have this angle here, that is the one up here, right? Like this one, this angle. I have a side angle side scenario up there. Do you see it? Side angle. So I'm not going to highlight anything just yet. I'm going to wait a little bit. But so I'm going to use that in a bit. So I'm going to park that there. Here's something interesting. Let's look at this triangle right here. If you were to start and solve this, sine of 27. So come with me over to the second triangle here. Sine of 27 over 25 is equal to sine of F2 over 30. What do you see? Like this setup versus that setup. Isn't it exactly the same? So why bother? Like, are we going to get the same answer? Yes, we are. We're going to get the same answer. So I'm going to go like this. Angle F2 is 33.01. Why is it doing that? Because sine always returns an acute angle, always. But can't we can clearly tell this is obtuse, right? So I will go, but angle F2 is obtuse. So that's where you have to watch out. Okay, so angle F2 is really 180 minus 33.01. Angle F2, if I look at my key here, is 146.99. Underline that. And I will add something beside here. This angle right here is really F1. You see it? Okay. So do this next to it. Angle F2 is 180 minus angle F1. That is very important. I am going to skip this step from now on. I'm not even going to go there because I know that I will get the same answer, but I don't want the acute angle. I want the obtuse. So I'm going to go 180 minus this one that I found, and then I will automatically get that F2 on this side, on the second triangle. Yeah. If I don't know if this is going to throw you off, what I'm going to do on my key, I'm not even going to show this step anymore. I'm going to go here, and then I'm going to automatically skip over to this step here.
So you can just write angle F2 equals 180 minus whatever you get there.
Yes. Yes. I just wanted you to see it that even if you were to go the other way, you would have to subtract from 180. You may skip this, so I will say that. Skip. Not classes, just that. Okay. Mr. Dixon said skip. Look, here are my notes. And then angle E2, because now I have two angles as well. Careful, careful. 180 minus 27, right? The one angle that I know, this one, minus this one that I just found. So 180 minus that, it's a very small angle. It's 6.01 if you're following. And so now, if you have the highlighters, let me see, I want to be careful here. So this angle right here, it's nice if you can do one of those, right? You're like, yeah, that's that one. And the angle F2 here, right? Tell yourself that that's that one right there. I think that's going to make a big difference when you flip through your notes, right? You're like, okay, all right, that's where that's from, right? And only watch me do this. If it's going to throw you off, don't add it to your diagram. But you almost want to think of this side as swinging over and coming over here. And right, like these are actually the same angles, right? Like this side swings, closes there, swings out, closes there. So the green can be put on both if you wanted to, right? Because it's right, like it's the swinging of the string there. All right, so we're not done yet. We need to figure out E. And this is where I like to use cosine law. You can use sine law if you want, but this is where I use cosine law because for both of them I have SAS because I do know this one up here now. So I do have an SAS up top, and then I can easily find the side across from it. So this is how I do it. Maybe it's probably a good idea to close this here. So for side E1, E1 squared is going to be the 30 squared plus the 25 squared, right? The two sides that you're given, minus 2 times 30 times 25 times cosine. Cosine of what? It's the angle that's across the side you're trying to find. So it's 119.99. So if you can fit it on that left-hand side to just kind of keep everything on the left-hand side for the first triangle, that is great. If you don't, not a big deal. Just make sure you write it down with the correct letters and you're just fine. E1 is therefore square root of, if I type all of this in, you get, notice that the square is now gone, right? Because I'm square rooting. So that's 2274.773. So 2274.773, and that keeps going. So E1 is 47.69 miles. And that I will box in. All of that journey just to find. But Obviously, it's a little bit slower because I'm walking you through it. When you do it, you will be faster. And I'm gonna kind of cut it here. Not all the way because I want to have my statement at the bottom here. So I'm gonna go E2, right? E sub 2 squared. It's almost like a weird chemistry formula there. That's 30 squared plus 25 squared minus 2 times 30 times 25. So it looks identical. Look at that. They look identical at first, except for at the very end, the angle is different. That's another reason why I like to use cosine law for this one. And so E sub 2 is square root of this whole thing. If you type that in one shot, you get 33.271, and it keeps on going. So E2, if you take the square root, is 5.77 miles. So E2, right, side E is 47.69 miles or 5.77 miles. So in the back of the textbook, if you're doing the homework and it is in fact a two triangle situation, it will give you both answers. It'll say it's either this or it's that. So that is the ambiguous case of the sine law, and this is as far as you can get, right? So you need to understand this. It's not always going to be the full-blown solve. I could have made it stop right here. I could have asked you what is the value of angle E, and then it would have only been these two, right? Like once you got to here, you're done, right? Or I could have asked you what is the measure of angle F. You would have stopped right there. So this is as far as you can get fully solving both triangles. Don't always think it's going to be like that. Okay. 22 minutes. It took us 22 minutes, right? So I think you could do it probably, if you did it yourself, probably in half the time, because I'm not explaining and doing all of that, right? So I was planning on only doing one and letting you will have half an hour to do it. So technically, you should be just fine. I want you to try it with this one. And I gave you the answers. Watch this, right? So you know what you're supposed to get. Okay? You know what the answer is. Would you be able to do it? Like the full-blown, figure out if it's SSA. If it is, how many triangles. Go through the whole thing and get to the end. So I'll let you have the rest of today's class to do that. And let me see here. Then it's word problems. Oh, you want to stay away from that one. I'll pause. I'm going to work this out quietly. So if you are stuck, does it. Just have to be consistent. And again, you may use sine law for this step here instead of cosine law. Go for it. You should get the same answers. There's one more thing. One more thing. 5 minutes of your time. So you got this. If not, it's on the video. So you got to go back a little bit to page 40. Oh, before I do that, this stuff right here, this stuff is on page 10 in the workbook, and I posted the key just now. This cumulative review, if you want to do it, like inequalities, that's up to you. The key doesn't have the key to that, so it's really up to you if you want to do it. Let's go back to page 40. I'll do one and the rest, I'll leave that up to you. But this is a conceptual thing. So please go to 40 with me here real quick. Triangle QRS, Q is 37, QS is 36 centimeters. So it's a different notation, shouldn't throw us off that much. Determine the height of the triangle from base QR. This is the key here. When I give you that, I expect you to know that QR is going to be down here. Okay? And because the angle they gave me is Q, I'll put Q on this side. Q, and this would be R out here. And so what is left? Q, R, this would be S, right, technically? This is on page 40. So angle Q is given at 37 degrees. QS is this one here. So I'll be pretty much giving it away as to what it should look like. Okay, this is the base. Okay, and so determine the height. They want us to determine the height of this triangle. So right off the bat, we go 36 times sine of 37. And that is 21.67 centimeters. Now, that would be answering that part. And now here comes ABC. This is where you need to show me whether or not you understand what's happening. What do you need? What does RS? RS is this one right here. RS is, right, like we're not sure if it's going to close it, but RS is really referring to that side right there. What would that have to be so that no triangle is possible? No triangle is possible. So it would have to be RS would have to be less than what? 2167. 2167. So anything less than 2167, because that's our height. We need this green part to be at least 2167, but if it's smaller, you have no triangle. So this would be how you answer that. What's the length of RS? So that you have one oblique triangle. What is oblique? Well, oblique is just a non-right triangle. So you would have to make RS would have to be greater than or equal to, this is the string, right? String. And this is rod. The string would have to be greater than or equal to 36 centimeters, which is the rod. If this is greater than or equal to, then you have that one oblique triangle, you're done. Okay? Automatically. Let's put this one on the side. String is greater than or equal to rod. And here, string is less than height. That's really what I'm doing, except for instead of rod, height, and all of that, we're replacing it with actual numbers that we're getting from this example here. The length of RS, so that two triangles are possible. This is the tricky one. This is the tricky one. So I would say this, RS, put RS in the middle. It would have to be greater than the height, which is 21.67 centimeter. But it would have to be less than what? The rod, which is 36. Does that make sense? This is the tricky one. Right? RS would have to be smaller than the rod, but greater than the height. I will allow you to do that in two separate steps if you rather want to do that. You state this first, and then you state this second. If you want to do it, that's fine. The length of RS, so that if there's one right triangle, what would that be? RS would have to be exactly equal to the height. I just want you to be prepared for this. If it ever comes your way, you know how to do that. If you want to give that a try at the bottom one there, you try. I will give you the answers tomorrow to do that one. Thank you guys. You've got 4 minutes to spare, lots of time.